now we move on to the last section of our technical research. So in the succeeding slides, I will discuss the results of economic analysis and decarbonization of the CNG transport case study. CNG, or the compressed natural gas. Case studies in Europe, North America, South America, and Asia showed that CNG buses can be a viable alternative for intercity and intracity deployment. Upon the introduction of natural gas vehicles, or NGVs, in the market, several countries adopted the technology, with Argentina, Brazil, Pakistan, Iran, and India leading in terms of the number of NGVs deployed. Reduction of GHG emissions is a primary reason for switching to NGVs. The technical aspect will follow the generic design provided earlier, and we will not discuss it here in this section. And the study takes the case of the Batangas-Manila route for evaluation, covering a total distance of approximately 108 kilometers between the two endpoints. Financial analysis was carried out to determine the viability of the project. The transport case study is appraised using the net present value, or NPV, and internal rate of return, or IRR, of the project criterion. The projected cash flow statement was constructed using available information gathered through review of related literature. So no primary data was collected for the study. Data for the costs and revenue of CNG bus operations were calculated, and the rest of the data for capital investments, and operation costs were derived from previous studies or estimated using the cost indices provided by Peters et al. Assumptions include fast fill CNG refueling stations and transportation of fuel via virtual pipelines. The table summarizes the estimated parameter values for the CNG buses. The useful life of the the table summarizes the estimated parameter values for the CNG buses. The useful life of the buses was assumed at 15 years, and the number of buses to be deployed is 250. This table presents a summary of the costs accounted for CNG vehicles and refilling stations. The cost of the CNG bus and fast fill CNG fuel station were adopted from data in journal articles. Pre-operating expenses, which include engineering and regulatory expenses, and the virtual pipeline system was estimated using an index from, again, Peters et al. The annual revenue was computed using the current fare and assumption of the annual bus operation. The fuel price was adopted from the study of USAID, valued at $7.27 per million metric BTU, delivered at X ship cost. The computation of the NPV and IRR gives a value of $2 million and 13.4% respectively, implying that the case study is financially feasible. This table shows that diesel and CNG are almost at par in terms of their fuel economy and approximate mileage per day. These are based on the Millennium Cities database for sustainable transport and from oral interview with officers of the Land Transportation Office and some drivers. A study shows that CNG buses have a global warming potential, or GWP, of 1.67 kilograms carbon dioxide equivalent per kilometer. Compared to the GWP of diesel buses, which is 2.14 kilograms carbon dioxide equivalent per kilometer, CNG buses can provide a GHG savings of at least 20% reduction. Findings in the life cycle analysis of CNG buses indicate that the switch from diesel to CNG or electric buses would constitute a reduction in resource depletion and in overall damage to human and environmental health by about 37 to 41%. The supply of CNG and the abundance of refueling stations are two important determinants in the successful rollout and sustainability of a CNG bus project. For instance, the EU requirement calls for the establishment of CNG refueling stations every 150 kilometers. Given that the natural gas market in transport application is not developed in the Philippines yet, investments would have to bear the initially high capital cost of establishing necessary CNG transport infrastructure. Further studies using primary data and cost estimates can be conducted to ascertain the financial and decarbonization findings of the study. So to conclude, our technical report on the power and non-power applications of natural gas presents findings on 4 major aspects. So at this point, we now highlight some key recommendations from our report. First, combined cycle power plants have high efficiencies, but process improvements could still be implemented to improve combustion efficiency and heat transfer. Since natural gas is touted to be a transition fuel, its use should be coupled with additional CO2 mitigation strategies to ensure a streamlined transition to a zero carbon future. We have outlined a few of these strategies in our report, and should you wish to retrieve a copy of our report, I will link you to our GPDP team. Next is the compatibility of existing equipment remains to be the topmost consideration of Philippine locators when it comes to fuel switching. Fuel switching in the industrial sector can be categorized depending on the power mix of a certain location. And lastly, the adoption of CNG buses as an alternative means for public transport mitigates the pernicious effects of road transport pollution caused by diesel-powered trucks. The natural gas market in the Philippines, especially for transport application, is quite new and would thus have to bear the burden of high initial capital costs on necessary transport infrastructures. And that ends our presentation. Thank you very much for listening.